Assalamualaikum and a very good day to you all. In this video, I would like to discuss with you about composite functions. Okay, before we go through these 4 examples, okay, maybe we need to visualize the process by a diagram or some sort, yeah. So, basically, if you have an object over here, yeah, and then we have the image. So when it went to the f, a process, a function, so it becomes fx because we insert x inside f. Now, what happens with the composite is that we add another process to the image fx. Okay, so fx is the image. We put the image inside another function, or namely g. Okay, so it becomes g f x. Okay, so this is the process. So the whole thing is g composite f x. Okay, so this is what it means, yeah. So basically, composite is just a typical functions. But before this, the x that we put here, okay, is the object. Okay. Now, what happened in composite that we put the object, we put the function or any function as the object. So that's the only difference. Okay. So, okay, I hope the diagram will help you. Okay. So let's get started with these things. Yeah. Okay, now let's see. Okay, so we have been given 2 equations there, 2 functions. So let's get started with this one. So g composite f3, eh? So it is g f3. F3 is fx here with 3, so 2 3 minus 1. Okay, and then g is x cube, so we need to cube all the previous answers. So 2 3 6 5, so 5 cube is 1 2 5. Correct. Correct. Okay, now we continue with this one. Okay, so f composite g3 equals f with the inside of g3. Okay, what G3 is? G3, what G3 is? G3 is, where is G? Oh, G is that one, huh? So 3 3, okay, 3 3 is 81, 27. Okay, 27. So F is double that 27 minus 1. So 54, yeah lah. 54, 53. Okay, now what we can see from these first 2 examples is that G composite F, okay, is never equal to F composite G. You see, even though you see the letter are next to each other, the order is important. Okay, because G is having fx as the object, while f is having gx as its object. So it's different. It's like wearing it's like you wear sock first. Okay, you wear sock first. So let fx become wear socks, and gx becomes wear shoes. Now from there we know already. Okay, like for this left one, means we wear sock first, and then we wear our shoes, right? So that's my diagram of shoes. Okay, now what happens if we do otherwise? What happens if we wear our shoes and then we wear our socks? This is what happens. Okay, so this is our leg. Where is our leg? Leg. This is our leg also. Leg. You see, different, right? So if you feel stuck or whatever, you remember the analogy of wear sock first and wear shoe later is not equal to wear shoe first and wear socks later. Okay, now let's proceed. F2 and F3. Okay, now F2 berapa tadi? F2 3. F2 3. Okay, F2 is this one, sometimes they call F square or something like that. This one equals to F3. Okay, so it means that we have F3, 3 inside F, inside another F. Okay, it's like onion some more, layer in layer. Wait, F is 1, 2x minus 1. Okay, so this one no need to do first. 3, so 2, 3 minus 1. Okay, and then 2, 3 minus 1, 6, 5, and then we apply the same thing. 5 minus 1. Okay, so we have 9. Okay, now how about the other one? F3 bracket square. Okay, this one is different because the square is outside. Okay, let's consider this one. If we have x minus 1, we put square outside the square, the bracket, what will happen? It equals x minus 1 multiply x minus 1. Correct? Multiply, right? So same goes to this one. We just copy paste the box bracket. Okay? And then copy paste the content. Okay, wait, 3. I put 3. And then F3. Okay. Then, okay, padam all this. Now, okay, what F3x is? 2, 3 minus 1. Okay, box still there. Nothing changed. Okay, minus 1. So what we have is 9. Okay, multiply by 9, which is 81. So from this example as well, we can see that f square x is never equals to fx outside square. Okay, so I hope this from this you get the idea about composite function. Yeah. Okay, so maybe we can do how many examples do we have? Oh, maybe 2 more. Okay, this is one example. Another example of composite. Okay, now let's solve this one. Okay, given fx, a single function, and then we have another function that has been composite. Now, what to do? Simple. F composite G is simply gx inside f. Okay, so 2 square minus 1. Now, the one that we need to find is inside. This one inside, right? Inside, right? Okay, so if we are going to find the function inside another function, then it is easier. Okay, inside is easier. So maybe I write the keyword again. Inside is easier. Okay, now how to get this one? How to proceed? Very easy. We look from the fx here. Okay, I write it here. Maybe in red lah. Okay, in red. You see here. Okay, put here. So if it's fx, then it's 2 plus x squared. Now, what happens if I change x from x to become gx? 2 plus gx square. Okay. Oh, excuse me. Then now you see this one same, right? What to do? This one copy there. Okay, so 2 plus gx square equals 2x square minus 1. Okay, now from here solve lah. Okay, so 2x square minus 1 minus 2, and then the square I have make a square root. So what we have is 2x square minus 3. So this is the function of gx. Okay, now let's look the other one. Now we have we have another situation. We have a compound here, compound, and then we have a single function here. Okay, now where the gx that we need to find? You see it's outside, right? Just now I said inside is easy. Inside is easy. Okay. Inside is easier. Easier. Outside is easy. Why easy? Because we just need to apply the inverse function from the previous video that you've learned. Now, if we insert the inverse inside a function of its own function, then we will get x, right? Now, from g f x here, what we can do is g composite f is simply g f inside a g. Okay? Now, we want to turn this fx to become x. In order to do that, we need to insert, maybe blank, outside g, we have to insert the inverse inside the f here. Then, it will become gx. Okay? Okay, tak apa. We do one by one. Don't panic. Okay? Okay, wait, sorry. Need to highlight. Okay, now, don't worry so much. The first step is find the inverse of fx. So, find inverse of inside function. So, what is the inside function? Fx lah. This one inside, right? Okay. So, find the inverse. What the inverse? F inverse x. Okay. 1 over f inverse square. Okay. This one becomes x. Okay. So, 1 over f inverse x square. Oh, I put like this, Sorry. Need to put the bracket properly. Square. Okay. Then switch places f inverse x square 1 over x. Okay. And then f inverse x is 1 over third x. Okay. So we have the inverse right now. And second, insert f inverse f inverse both sides. Okay, in the composite lah, inside here. Okay, now what we have there is g composite f x. Don't want lah to write like that. I change already lah. Confusing some more. The circle, the confusing one. Okay, initially we have this, right? Square. Okay, now what is the second step just now? We change this x into f inverse. Okay, so we put f inverse inside f and then inside g. Now, when we change this, when this is this one, right? So, when is the x become f inverse? 1 over, what's the, okay, that one. Okay, 1 over third x. Okay, now, by principle, by the rules of inverse, f inverse is x. Okay, now we are getting closer to our gx. Okay, so for this one, maybe we need to change the x becomes x negative half. Yeah, it's easier. Now, that one, so minus half multiplied by 2 is minus 1. So 1 over x minus 1. Okay, 1 over the whole thing is the whole thing minus 1. Okay, the whole thing minus 1. And the whole thing is x minus 1. So it's a bracket. So minus 1 multiply minus 1 is 1, positive 1. So the answer is x. Okay, so maybe I just zoom in out for you to see the whole idea. Okay, and then yeah, let's maybe I scroll this one. Okay, scroll this one. Maybe you need to pause to see the whole thing. Okay, now let's do one more example, shall we? Okay, padam this one. Later kacau some more. Okay, good. Now, what's this? Looks horrible. If f composite g is that one and gx is that one, find the composite function of gf. Hence, find the values of x that satisfy those things. Okay. Well, first thing first, we need to find fx lah. Okay. So we have f composite gx. Fx, okay, 4x squared minus 2x plus 1. And then we have gx, 2x plus 1. Okay, now, the one that we have to find is outside. Okay. So, we need to find the inverse of the inside. Okay. So, find outside, inverse the inside. Okay. Now, what is the inverse of gx? Gx equals to g inverse plus 1. Gx plus gg inverse, I'm sorry. So this whole lot become x, 2g inverse x plus 1. Okay, and then x minus 1, 2g inverse x. And then g inverse x equals x minus 1 over 2. Okay, now we have the inverse already. We put it on both sides. Okay, both sides, left and right. So what we have is f, g, put g, maybe red lah, red color. Red color. Can see also, not confused. Okay, but over here also must right lah. Okay, g inverse x minus 2 plus 1. Okay, I'm sorry, make a line lah there, not confused. G inverse x. Okay, then we solve lah. So this one become fx equals, square, forgot, sorry. So 4 g inverse, that one lah. I'm sorry. The g inverse is this one lah. Yeah, correct. X minus 1 over 2 square. Okay, right hand side minus 2, x minus 1 over 2 plus 1. Okay, so now I zoom over here to solve it further. Okay, then that one x minus 1 square lah, don't want lah to expand, malas some more. Okay, d2 cancel some more, minus 1 plus 1. Okay, also cancel, minus 1 square. What's this? Minus x plus 1 plus 1 plus 1 plus 2 lah. Okay, so this is our f. And Assalamualaikum and a very good day. Just a few correction, not really correction lah, correct already. I just don't want to confuse. For this extra example, the first part, the composite part, you see I wrote here g inverse on the right hand side, right? This one little bit wrong. It's correct, but it will make you confused because, okay, you see, you get the inverse on the right hand side here, over here, right? Now, you see what I'm trying to say, that this one you substitute here, okay? Because this one on the left hand side, you substitute left hand side also. But this one on the right hand side of the equal sign here. So we are substituting these things inside here, okay? So x minus 1 over 2, x minus 1 over 2. And then the rest are the same lah, okay? Thank you, that's all. Assalamualaikum plus 2 lah. Okay, so this is our fx. Okay, now find the composite of gf. Gf. So what g is? G is 2x minus 1. 2x plus 1, sorry. So gfx is gf. F, we copy lah this. Okay, copy only, easy some more. Copy. Okay, now and then this one lah. Okay, now we know gx will turn at every object, will double the object. double je object plus 1. So what is the object? Paste. Okay. Padamlah. Sorry. Paste. We paste this one. 2x minus 1 square. Never bring these two inside. I kill you, then you know. Okay, minus 2x, because so many people did that. Frustrating, you know. Because the power are not the same. Cannot put inside. Leave it be like that. Okay, 2x plus 5. Then. Yeah, that one. That's it. That's all. Okay, GF. GF done. Find the composite. Okay, done. GF done. Hence, find the value. Okay. Now, we have F composite G here, right? This one, right? Sorry, this one. Okay, this one, right? Have. Copy. So, paste lah. Okay. Because they gave the condition already. Okay. Copy. Paste. I left the 5. Okay. Because it says, find x when f g x equals gfx. Okay, we move a bit further down lah, confuse some more. Okay, so find x if this one. Okay, now we do lah. Okay, so we need to expand that after all. 2x minus 1, minus 2x plus 5, 4x squared minus 2x plus 1. This one 2x squared minus 4x berapa ni? Plus 2 minus 2x plus 5. 4x squared minus 2x plus 1. What to do? X squared, get rid. I think bring everything here over there lah, easy. So 0 minus 2x squared minus 4x minus 2x 8. Alamak. Cannot. Solve this one first. 2x squared minus 4x minus 6 lah. Minus 6x plus 7. And then 0 minus 4x squared plus 2x minus 1. So I have minus 2x squared minus 2x squared minus 2x squared minus 4x plus 6. Okay. Horrible. Change it like this lah. Suddenly. Okay, so x squared plus 4x minus 3. Minus 3. Sorry. Can also. Nantilah. 6 first. Okay. Can potong the 2 also. So x squared plus 2x minus 3. Can. So 3, 1 plus minus x. Can. Okay. So from here, x equals minus 3 and x equals 1. So the value of x that will satisfy f composite G equals G composite F is x minus 3 and or x equals 1. So thank you for your time and attention. Assalamualaikum. Have a good day.